Hello everyone, we are going to study the IV characteristics of light emitting diode. So, first the question arises, what is LED? In the simplest terms, a light emitting diode, LED, is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor material. LED is basically just a specialized type of diode as they have very similar electrical characteristics to a PN junction diode. This means that an LED will pass current in its forward direction but block the flow of current in the reverse direction. Light emitting diodes are made from a very thin layer of fairly heavily doped semiconductor material, and depending on the semiconductor material used and the amount of doping, when forward biased, an LED will emit a colored light at a particular spectral wavelength. LEDs are comprised of compound semiconductor materials which are made up of elements from group 3 and group 5 of the periodic table. The main semiconductor materials used to manufacture LEDs are: first, indium gallium nitride, which is used for the manufacture of blue, green and ultraviolet high brightness LEDs. Second, aluminium gallium indium phosphide, which is used for the manufacture of yellow, orange and red high brightness LEDs. Third, aluminium gallium arsenide, which is used for the manufacture of red and infrared LEDs. And fourth, gallium phosphide, which is used for the manufacture of yellow and green LEDs. Now, let us understand how LED works. When the negative end of the circuit is hooked up to the N-type layer and the positive end is hooked up to the P-type layer, electrons and holes start moving and the depletion zone disappears. When the positive end of the circuit is hooked up to the N-type layer and the negative end is hooked up to the P-type layer, free electrons collect on one end of the diode and holes collect on the other. The depletion zone gets bigger. When current flows across a diode, negative electrons move one way and positive holes move the other way. The holes exist at a lower energy level than the free electrons. Therefore, when a free electron falls, it loses energy. This energy is emitted in a form of a photon, which causes light. The color of the light is determined by the fall of the electron and hence energy level of the photon. The term hole has been used here, so let us understand what is a hole. Hole is not always in a semiconductor. It can be in any material. A hole, as the name suggests, is simply a vacancy created by an electron when it moves from its initial site to some other location. Actually, there is no physical thing which we call as hole. It is just the absence of electron from the expected site of its presence. In semiconductors, if we dope any p-type impurity, then a huge vacancy of electrons would be created. We call these vacancies as holes. Only the absence of electron does not mean a hole, but the absence of an electron from an expected place of its presence is a hole. These two things are totally different. Now, let us proceed towards the experiment. The apparatus used to determine the IV characteristics of LED are: first, LEDs, second, breadboard, third, connecting wires, fourth, ammeter, fifth, voltmeter, sixth, DC supply, and a resistor. This is the circuit diagram of the light emitting diode. In this, first connection is the positive end of the battery is connected to the positive end of the emitter. Here, in between, we have connected a resistor which is used to limit the current through the LED and to prevent the LED from burning. Now, another connection is the negative end of the ammeter which is connected to the positive end of the LED, that is anode. Next connection is of the negative end of the LED, that is cathode, is connected to the negative terminal of the battery. Now, moving to the parallel connections, the voltmeter positive end is connected to the battery's positive end. The negative terminal of the battery is connected to the negative terminal of the voltmeter. Now, again, the positive end of the voltmeter is connected to the positive term of the LED and the negative end of the voltmeter is connected to the negative terminal of the LED. Now, with the help of all the components, we assemble the circuit diagram as shown in the figure. Now switch on the power supply. The voltage is set at 2 volts and the current through the LED shown by our ammeter is recorded. With the help of slider of rheostat, the voltage is increased in steps of 0.1 volt. For each setting of the voltage, corresponding current shown by the microammeter is noted. Here, by using white LED, the observations have been recorded, and a graph is plotted of forward voltage versus forward current of the LED. Similarly, take different LEDs and do the same procedure. We will observe that the infrared LED has the lowest forward voltage. The forward voltage of LED goes on increasing in the order of red, orange, yellow, green, blue and white. This is due to the different composition of semiconductor material used in the LEDs. Also, the LED with less wavelength has more forward voltage. So, this is how we determine the IV characteristics of LED. Thank you for watching.